Hey everyone, in this video, as it says, we're going to be reviewing solving an equation involving logs. So I'm going to do two examples. The first one will be solve for x. And here's the equation. Log base 4 of x minus 5 equals 1 minus log base 4 of x minus 2. Alright, so one thing we've already learned in this chapter is, or about logs, is the properties of logs. So when you're solving for x, one strategy is to get your logarithms together and try to condense them into one. So our logs are currently not together, so what I'm going to do is I'm going to add this log to both sides. And that will give me log base 4 of x minus 5 plus log base 4 of x minus 2 equals 1. So I just move this to the left side. Now, because I've got two logs with the same base and they're adding, I'm going to use the product property, and I'm going to rewrite this as log base 4. And I'm going to have x minus 5 times x minus 2. I know you have a couple options. You could either multiply this out or we could rewrite it in exponential form. Doesn't really matter which way we go. So I'm going to just multiply it out. So x times x is x squared, and then we'll have negative 2x minus 5x, so that's going to be negative 7x, and negative 5 times negative 2 is positive 10. Alright, now I want to solve for this, but I can't because we're taking the log, right? So in order to get x by itself, I need to rewrite this in exponential form. So that's going to be 4 to the first power equals x squared minus 7x plus 10. And now your mind should be thinking quadratic, and if we want to solve a quadratic, this needs to equal 0. So this is 4 to the first, so it's just 4. So I'm going to move this to the right-hand side. And 10 minus 4 is positive 6. And now I can factor. This factors super nicely, right? What multiplies to 6 and adds to negative 7? That's going to be negative 6 and negative 1. Then I can use the zero product property to set each factor equal to 0, and we get x equals 6 and x equals 1. And if you think we're done, you are unfortunately incorrect. Right? We are not done because logarithms, remember, cannot be negative. So we need to do a check and make sure that these solutions work. So I'm now going to do a check. And I'm going to start by substituting x equals 6 into the original equation. So I will have log base 4 of 6 minus 5 equals 1 minus log base 4 of 6 minus 2. And when I simplify, we get log base 4 of 6 minus 5 is 1. And 1 minus log base 4 of 6 minus 2, which is 4. And because these are positive, we know that this is possible. If you wanted to, you could use a calculator. If you have a graphing calculator, I can show you how to do this. And we can actually simplify both sides. So in a TI-84 plus, you're going to go to math, and you're going to, under math, go all the way down until you see log base, hit enter, and then there you go. So log base 4 of 1 is 0. And then I could do 1 minus, and then I need to go back to math, back to log base 4 of 4. So I've confirmed again, but you could stop here. So it looks like 6 is in fact a solution. Now let's check x equals 1. And even right when you're writing, you might know exactly what's going to happen here because 1 is smaller than 5 and we're subtracting. But you really should show all of your work because remember we're trying to communicate why. So it's almost like a little algebraic proof. So 1 minus 5 is -4. And 1 minus 2 is -1. And so this is not a solution, right? X equals 1 is not a solution because you cannot take the log of a negative number. So we could even label this, right? 1 is extraneous. Okay, so now we are completely done because we've done 2 checks and we know we have 1 solution and an extraneous solution. So for my next example, we're going to do another solving problem. Log base, or we'll just do base 10. Oops. So log of x equals log of 5 plus log of x minus 5. So similar idea, right? We want to try to combine logs if we can. Now we have an x here and an x here, but these are being added together, so we can condense this quite easily, and that's what we're going to do first. So I'm going to just bring down the left side, and then I'm going to use the product property. So that'll be 5 times x minus 5. Now, we're at a point where we can use what's called the property of equality. So because we have log base 10 of the same of 2 things, right? But these are both log base 10. We're going to use the property of equality and say that x is equal to, I'm just going to distribute this, 5x minus 25. So what we did here is we used the property of equality for logs, which states if you have log base b of x equaling log base b of y, then we know that x equals y, right? So if they have the same bases, they're equal, then we can assume that these 2 things are equivalent as well. And that makes this problem a lot easier. At this point, this is algebra 1. So we're going to subtract 5 from both sides. 1 minus 5 is -4. And then I want x by itself, so I'm going to divide by -4, and I get x equals negative divided by a negative is a positive. And we're just going to leave that as an improper fraction. Now we don't know if this is a solution or not, so we do need to do a check. So I'm going to substitute in 25/4, so we have log of 25/4. So far, so good. It looks promising. Equals log of 5 plus log of 25/4 minus 5. And then, oops, bring everything down. I'm going to get a common denominator here. So I'm going to change this denominator from 1 to 4, so that means that this is 20, and 25 minus 20 is 5. So that means I have log of positive 25/4 equals log of 5 plus log of 5/4. Because all of these are positive, we're golden. And if you wanted to, you could do the product property, right? And then that would be log of 25/4 equals 5 times 5/4, which is 25/4. So that's a nice quick check. So those are 2 examples of problems where you're solving an equation involving logs. Make sure you check your answer anytime your variables are within the log because you could end up with extraneous solutions.